Hello everyone and welcome again. In this video, I'm going to discuss a very basic difficulty which most of the beginners face while writing code in C++ or performing in competitive programming. So the situation is, let us say if you want to pass a 2D array to a function, okay? So the situation looks simple, like if I have, let us say, int my 2D array is matrix, let us say 3 rows and 3 columns. Okay, so something 3, 1, 2, 3, and then 4, 5, 6, and then 7, 8, 9, something like that. Why can't I simply pass it to, let us say, a function is print function? Why can't I simply pass it as met, right? And in this function, in the function definition, I will just define void print int met with empty array symbol, right? Why can't I do that? So this is not possible in C++. Let us see how it happens in Java. This is a simple Java code with me. Here, I have a class passing array to method. I have one array A, 2D array. Okay, these are the content, 3 rows and 3 columns, and I have a function accepted. In the function definition, I'm simply providing two, empty array square brackets, and I'm just printing it. So if I run it, it runs just fine. You can see that all the elements in rows and columns are printed. So this is how we pass a two-dimensional array in Java. But things are not this simple in case of C++. So in C++, what happens if I try to do exactly same thing like print 2D array is a function, and if I pass my met, which is my two-dimensional array, to a function, let us say, okay, let us take it this way. I'm not going to call this one. I have, let us say, a function test, and there I am passing met. Okay, and I will just define this function as void test. Here, I'll just receive it as met, like this. So it doesn't work like this. Why? You can see there is error. Okay, an array may not have elements of this type. So this is the problem statement or the difficulty which I'm going to discuss here. So what is the correct way of passing it? So in C++, there is no direct way to handle this kind of 2D array passing. Okay, so we need to provide, we need to handle this situation in a little different way. For this, for better explaining this, I need to show that how memory representation happens in, or memory allocation happens in the case of in case of any programming languages, or basically let us take paper. Okay, so if let us say I have one array which is having 2D array which is having 0, 1, 2 in first row, 3, 4, 5, 6, 7, 8. This is my 2D array. So how it is saved in the memory is based on the system, based on your machine architecture. Either the machine is a row major order or column major order. So in row major order, elements are saved in memory in this order: 0, 1, 2, 3, 4, 5, 6, 7, 8. In column major order, it will be saved like 0, 3, 6, okay, and then 1, 4, and 7, and then 2, 5, and 8. So in this order. But nowadays, all the machines are row major order. Okay, so we need not to focus on this. So now, if you know that your content is saved in the memory in this order, row major order, how you are going to access it. So basically, this is the exactly same way how our one-dimensional array is saved, right? So why can't we use the representation of one-dimensional to access any of the element, right? Because if we know the base address of 0 or the starting of the array, and if we just provide that, okay, after how many elements our, let us say this 5 is existing. So we know that, okay, 0 to 1, 2, 3, 4, 5, 6. So this is the sixth element, and this is exactly in the row major order sixth element. Okay, so if we provide a way to convert our two-dimensional representation into one-dimensional representation, then our job is done, right? So that is how exactly we will do it. So let us get back to the code. I'm deleting this part, okay? And so this is my array. And here I will pass the pointer of mat, which will be the head pointer or the first element address. And this is my function, okay? So here what is going to be done is int pointer to the first element. And I also need the information like how many number of rows and number of columns are there in this two-dimensional array. Basically, I don't need number of rows because I just need number of columns. Okay, because it is a row major order memory representation. So in that case, I don't need number of rows. So let me just remove the one parameter here. Okay. So yeah, and one comma. Yeah. Okay. So what is happening here is I'm passing the pointer to the matrix and I'm passing the number of columns. And then I'm finding that what is the, let us say if I want to access the 2,2 element. Okay, second row and second column in zero-based index system. So my 2,2 is basically this one, 8, right? So what will happen is I want that what is the representation of this 8 in one-dimensional representation. So here we have seen that it is 8th index, right? So I want to convert 2,2 to 8. I want a function which will convert 2,2 to 8. This to this. Sorry, this one. Okay. So what I can do is, let us say if this is R and this is C, and we have capital C as the number of column. So what I'll do is I will simply do R multiplied by number of columns plus small c. So this will give me R is 2 multiplied by number of columns 3 plus 2. Okay, it gives me 8. So this I have just written in a simple function format like get 1D index. So R multiplied by number of columns. So this. So if I run this, what will happen is, so yeah, just ignore this part. I'm just passing here one-dimensional array and testing it. So if you want to have a look, so one-dimensional array, we can pass it straight away. So here, one-dimensional index for 2,2 is 8, and inside the the matrix, in one-dimensional way, I am accessing the two-dimensional array. So this function is returning 8 and it is returning 8. So let us say if I want what is in 1, 2. Okay, so what is in the 1, 2? This is my 2D array. So first row and second column. So this is 5. So let us run it. So Yeah, so the index generator is 5. Okay, sorry, sorry. I need to change it here also. Okay, so you see, this is 5. So this is all about how we pass a two-dimensional array as a parameter in C++. In Java, it is straightforward, but in C++, if we know how memory allocation happens, then we can do a simple hack to achieve what we want. So thank you for being with me till now. And if you like this video, please like it and share it. And please subscribe it to support my effort. Thank you once again. Have a nice day.